Alright, so in this example we're told to consider a particle p who moves on a path within the Cartesian component space given by x of t is equal to t cubed plus 10 and y of t is equal to 2 times the cosine of 4t, where both of these components are given in inches and time is given in seconds respectively. And given this information in a particular instance in time, we're asked to find the velocity vector of p, the acceleration of p, and the angle between the velocity and acceleration vectors of p. So to do this, I'm going to note that in the plane, in Cartesian coordinates, that the velocity vector is given by x dot in the I direction, plus y dot in the j direction, and that the acceleration vector is given by x double dot in the I direction, plus y double dot in the j direction. And so given x and y, really if we want to solve this problem, we simply need to find time derivatives. So to do that, I'll first of all note that x is equal to t cubed plus 10, which means that if I want to compute the time derivative of that, I'll have 3 times t squared. And if I want to compute the second time derivative of that, I'll simply have 6 times t. If I do something similar with y here, we know y is equal to 2 times the cosine of 4t. If I take the time derivative of that to get y dot, I'm going to have minus 2 times 4 times the sine of 4t, which of course is simply minus 8 times the sine of 4t. And if I take the time derivative of that, I'll have that y double dot will simply be, in this case, minus 4 times 8, which is 32, times the cosine of 4t. Now that I have these values, I can go ahead and plug them back into v and a respectively to get the answers for both part A and part B of this problem. Now part C in this problem asks to find the angle between the velocity and acceleration vectors. And to do that, I'm going to take advantage of the dot product. So we can recall that the velocity vector dotted with the acceleration vector is going to equal the magnitude of the velocity vector times the magnitude of the acceleration vector times the cosine of the angle in between the two vectors. This of course means that theta, the angle between the two vectors, will be equal to the inverse cosine of quantity the velocity vector dotted with the acceleration vector divided by the magnitude of the velocity vector times the magnitude of the acceleration vector. If I go ahead and expand this quantity inside parentheses, what I'll have, taking the velocity vector and dotting it with the acceleration vector, I'm simply going to have x dot times x double dot plus y dot times y double dot, and then I need to divide by the magnitude of the velocity vector, which will be of course the square root of x dot squared plus y dot squared, times the magnitude of the acceleration vector, which will be the square root of x double dot squared plus y double dot squared. If I evaluate that arc cosine, I can find the angle of interest. Given that from here the rest of this problem is numerics, I'll leave it up to you to do. I know you can do so. Best of luck.